Hello everyone. In this session, we can discuss about the even and odd function. So first consider the even function. Even function. So a function. So what is the definition? A function f of x defined in the interval defined in the interval from minus a less than or equal to x less than or equals to a is said to be even if it satisfies the condition f of minus x is equals to f of x means, so by replacing the value of x in the function, that is in the given function f of x, we need to get back the same function. So that is the definition of the even function. So here we are replacing the value of x by minus x. So then we have to get the function f of x only. Then we'll call that as the even function. So how this graph of the even function looks? We can consider the function y is equals to x square. So if we consider the graph, so for an example, so y is equals to x square. So here f of x is equals to x square. It is a parabola. So if we plot this parabola, we will get a curve which is a parabola which is open towards the positive y-axis. So this is the curve y is equals to x square, which is symmetric about the y-axis, symmetric about the y-axis, symmetric about this y-axis. So what is the example we considered? Example, f of x is equals to x square, which is defined in the interval says some minus a less than or equal to x less than or equals to a, then f of minus x is equals to minus x whole square. So minus x whole square is will get f of x. So minus x whole square is will get x square. That is same as f of x. So therefore, so f of x is equals to x square is even function. So next is from the properties of the integral. So from the properties of integral, we can write. So the integration runs from minus a to a, f of x into dx is equals to 2 times integration runs from 0 to a, f of x into dx. So if f of x is even function, so the condition is the function must be the even function which is defined in the interval minus a to plus a. So this is the one of the important property of the integral we use recursively in the Fourier series. Next is, so what are the other examples for the even function? So if we consider few more examples, f of x is equals to cos x is an even function. F of x is equals to secant x, that is the reciprocal of cos x is an even function. If we consider the function f of x is equals to x power 4 or x power n. So x power n for even values of the function x power n is even. So this is about the even function. So next we can consider the other function, that is the odd function. So what is the definition? A function f of x defined in the interval minus a less than or equals to x less than or equals to b, sorry, less than or equals to a, is said to be less than or equals to a is said to be odd function if it has to satisfy the condition f of minus x is equals to minus f of x, means on replacing the value of x by minus x, we need to get the negative of the function. Then we can say that the given function is odd function. So what are the examples? The example is, consider the function f of x is equals to x cube. So if you replace x by minus x, we will get minus x whole cube. So minus x whole cube is minus x cube. So we got it as negative of the function minus f of x. So therefore, f of x is equals to x cube is an odd function, is an odd function. So how the graph of this looks? So if you plot the graph of y is equals to x cube, so it is a non-linear function. This is the graph of y is equals to x cube. It is symmetric about the origin. So it is symmetric about the origin. So the graph of odd function is symmetric about the origin. So next is the few more examples are, so if we consider the second example, f of x is equals to sin x. If we replace the value of x by minus x, we will get sin of minus x. Sin of minus theta is, we know that it has minus sin theta, we get minus sin x. So it is a negative of f of x. So therefore, sin x is odd function. So next is the from the property of integrals. So from the property of integral, we can write the integration runs from minus a to plus a, f of x into dx is equals to 0, where f of x is an odd function. So by combining the property of the integral in the case of even function and odd function, we can write this one as integration runs from minus a to a, f of x into dx can be written as 2 times integration runs from 0 to a, f of x into dx. So if f of x is an even function, so otherwise the value is 0 if f of x is a function. So this is the one of the important property we will use in evaluating the Fourier coefficients. Next is the properties of integrals. The properties of odd and even functions are, so first one is product of two even functions. The product of two even functions is even. So second one, the product of two odd functions is also even. Two odd functions is even. So third one is product of odd function and one even function is odd function. So these three are the important properties we will use. Now we can look into the how the even function and odd function nature affects the Fourier coefficient. So first is for the Euler coefficient A naught. So what is the formula for the Euler coefficient? So A naught is given by 2 by t. Integration runs from c to c plus t f of x into dx. If the function is even in the interval c to c plus t, so if f of x is even in the interval c to c plus t, then a naught is 4 by t. Integration runs from c to c plus t by 2 f of x into dx. In particular, if we take the function f of x is defined in, if f of x is defined in minus pi less than or equals to less than pi, then so what happens to the a naught? A naught is equals to 2 divided by 2 pi. Integration runs from minus pi to pi f of x into dx. So 2 to cancel, we will get 1 by pi. Integration runs from minus pi to pi f of x into dx. So now we will use the properties of the integrals. So this will take the form 2 by pi, integration runs from 0 to pi, f of x into dx. So if f of x is even, so 0 if f of x is odd function. So this is the property how we can use for the if the function is either odd or even to compute the value of a naught. Similarly, so an is given by 2 by 2 pi, integration runs from minus pi to pi, f of x into cos nx into dx. So to get the detailed information about this, so look into the first lecture on the Fourier series. So we will get 1 by pi, integration runs from minus pi to pi, f of x into cos nx into dx. So now this will take the form if the function f of x is even, if f of x is even, so f is the even function, we are taken f is even, cosine is also even, even into even is equals to even function. So the integral value takes the form 2 by pi, integration runs from 0 to pi, f of x into cos nx into dx. If the function is odd function, if f of x is odd function, so f of x is taken as odd function, cosine function is even, product of one odd and even is odd function. So integration from minus pi to pi, odd function value is 0. Similarly, bn is given by 2 by 2 pi, integration runs from minus pi to pi, f of x into sin nx into dx, so which is equals to 1 by pi, integration runs from minus pi to pi, f of x into sin nx into dx, so which is equal to, if f of x is even function, so here we are taking it as even function, so sine function is an odd function, product of one even function and odd function is odd function, so its value is 0. Next, if f of x is odd function, so we taken f of x is odd function, sin x is also odd, product of two odd functions is even function, so we can write it as 2 by pi, integration runs from 0 to pi, f of x into sin nx into dx. So therefore, in conclusion, we can write, so first one, if f of x is odd function, so first we can make a comment on even. If f of x is even function, the value of a naught and a n is not equal to 0, and so directly we can take the value of bn as 0. So no need to compute the value of Bn if the given function is even function. Next, if f of x is odd function, then directly we can take the value of a naught and an as 0, and we need to compute the value of bn. We need to compute the value of bn. So if the function is even function, compute a naught and an, and in the second case, if it is a odd function, compute only bn. So remaining two terms are taken as 0. This property will be used, means this concept will be used frequently in evaluating the Fourier coefficients without evaluating the integrals. Thank you.